think for a moment about something important. Where are we going in space? We've been traveling through space for a long time, it seems forever. But here's the question. Is there a reason for our journey, or should we reach a special place? Our solar system moves fast in space, about 450,000 miles per hour. Earth, our beautiful home, is safe in this part of space. It's not as scary here as it is for other space neighbors. But here's the catch. Something big is going around Earth, and if it falls apart, it might destroy our planet. Let's take a journey into space, about 220 million light years away, where scientists have come upon something pretty extraordinary. They call it a gravitational anomaly. Our galaxy and 100,000 of our neighboring galaxies are hurtling towards a massive point in the universe. The tricky part, we have yet to learn what's there. That's why we call it the Great Attractor. How big and strong is this area? Remember that the majority of the 300 billion stars in the Milky Way are far smaller than our Sun. The Great Attractor is thought to be the size of a quadrillion suns. To begin, we must recognize that the cosmos is expanding. It has increased to 2.2 million kilometers per age since the Big Bang. That implies that our galaxy and Andromeda, our neighboring galaxy, should be moving at the same rate. Well, not precisely. So a few years later, we realized something interesting. It's not just us moving in a specific direction, but everything around us, spread across hundreds of millions of light years, is going the same way. Now, normally things in space should be spreading out due to the Big Bang, but something is pulling them back. What's the cosmic tug-of-war champ? Good old gravity. Take Andromeda, for example. It should be moving away from us, but guess what? We're on a collision course with it in about 4 billion years. Why? Because a big bunch of stuff like stars and galaxies has enough mass to fight against the usual cosmic spreading. At first, scientists thought our speedy movement was because we were on the edge of the Virgo supercluster, a massive collection of 1,300 galaxies. But even that giant wasn't hefty enough to cause these cosmic surprises. We are heading toward the Virgo supercluster due to the same phenomena that caused our collision with Andromeda, groupings and clusters organically condensing. Why is it so difficult to look at this mysterious Great Attractor? Because our galaxy blocks our vision. A part of the universe is hidden from us. All right. Imagine looking at the night sky and seeing the beautiful Milky Way. It's like a cosmic painting. But here's the catch. This stunning view also blocks sight of a chunk of the universe around us. About 20% is hidden behind our galaxy, making it tricky for astronomers to figure out what's out there. The first time evidence of the existence of the Great Attractor was discovered in the 1970s. At that time, scientists didn't have the equipment to see through the zone of avoidance, which blocks most of the visible light from beyond. The good news is that this gas and light can't block all infrared and X-ray light. So when X-ray astronomy became more powerful, people got the opportunity to sneak a peek at objects dwelling in that region. But the pictures could be clearer than we'd like them to be. Guess what they found when they looked past this cosmic blind spot? A supercluster of galaxies, now known as the Norma cluster, chilling 150 million light-years away in the Great Attractor's neighborhood. And behind that, there's an even bigger supercluster, the Shapley supercluster, a whopping 650 million light-years away. It holds the mass of 10,000 Milky Way galaxies. Imagine that. It's one of the largest things we can see in the universe. Now, when we say supercluster, it's not just a bunch of galaxies hanging out. It's like a neighborhood in space where all the galaxies are moving towards a common center. The Virgo supercluster, for example, isn't its own thing. It's part of a much larger structure, the Laniakea supercluster. It's like galaxies teaming up and going on a cosmic journey together. This supercluster is the greatest galaxy cluster within 1 billion light years, and everything in the universe, Earth, the solar system, even the Great Attractor, is moving toward it. But at the moment, astronomers are still trying to find more information about the Great Attractor. The Hubble Space Telescope is now focused on the region of space where it resides. The largest galaxy visible in the region of the Norma cluster is ESO 137.002. a spiral galaxy with large clouds of dust across the galaxy's bulge. Unfortunately, being an optical telescope, Hubble can't see a tail of glowing X-rays extending out of the galaxy. Observing the Great Attractor is difficult at optical wavelengths. The plane of the Milky Way both outshines and obscures many objects behind it with dust. And even though we can get some information thanks to infrared or radio observations, the region behind the center of the Milky Way remains an almost complete mystery. In light of this, the Big Bang hypothesis of the universe's history and evolution is widely recognized. According to this theory, our universe formed 13.7 billion years ago as an incredibly hot and dense spot. However, how did it travel from such a small place to the enormous world that exists now and that we cannot see? Scientists are still unraveling what happened before, using clues from the cosmic microwave background containing radiation remnants from the Big Bang. During the universe's infancy, a rapid growth spurt called inflation occurred, allowing it to double in size many times. As it expanded, the universe cooled down. The early moments were intense. Chemical elements formed within the first 3 minutes, producing hydrogen and helium. After 380,000 years, the universe became transparent as electrons combined with nuclei to form neutral atoms, marking the end of the opaque plasma phase. The recombination era followed, ushering in darkness before stars and galaxies formed around 400 million years post-Big Bang. Reionization occurred as ultraviolet light from new structures eliminated surrounding neutral hydrogen, making the universe transparent to ultraviolet light for the first time. The solar system, including our sun, originated around 9 billion years after the Big Bang. Gravity caused a rotating nebula of dust and gas to collapse, forming a disk that eventually birthed the sun. The concept of dark matter emerged when astronomers realized there might be more mass in the universe than visible matter, suggesting the presence of exotic particles that don't interact with regular matter or light. Since the 1920s, astronomers have understood that the universe constantly expands. Surprisingly, recent observations revealed the universe is expanding faster today than in the past, contrary to expectations. This challenges the earlier belief that gravity from matter would slow or contract the universe. Current understanding suggests there's normal matter visible on Earth and in telescopic observations, and mysterious dark matter, shaping the evolution of our vast universe. The Great Attractor is the ultimate meeting point in space. It's like the VIP center of a supercluster, a huge gang of galaxies that includes ours and around 100,000 more. The Great Attractor isn't massive like a star or a planet. It's more like a specific spot where everything gathers, like the bottom of a cosmic bowl. Now, there are different theories about what this cosmic hotspot is. Some think it's a hangout for dark energy, whatever that is. Others believe it's a super-packed area with crazy strong gravity, pulling everything in. It's like a celestial magnet, pulling in all the galactic buddies around it. Some theories for the Great Attractor's existence include the convergence of dark energy or an extremely dense region with a strong gravitational attraction. Some scientists think that this is just a taste of what's to come in the end for the cosmos. After a few trillion years, the universe would condense after the big crunch when expansion slows down and starts to reverse. Eventually, this would result in the formation of a supermassive black hole which would eat everything, including itself. In simple terms, things are spreading out instead of coming together. There's a force called the Great Attractor that could pull everything towards it. But right now we're moving too slowly for it to affect us much. Even big groups of galaxies like Laniakea will eventually break apart. So, because we're expanding rather than collapsing, we won't ever get close to this mysterious Great Attractor. Many studies are going on, and some are pending. And who knows what change will occur in the universe when we meet this giant, mysterious Great Attractor? What do you think about it? Would it be possible? Let us know in the comments below.